Hello grade 8 students, I hope all of you are in a good and healthy condition so that you are ready to learn on this Penabur home learning session. Before we start, I would like to show you some pictures. We start with the first picture. Do you know who is in the picture? Don't say that you are fans of Iron Man if you don't know this man. Yes, he is the same person. He is Robert Downey Jr., but at this picture, he is not become Iron Man. He becomes Sherlock Holmes. The next picture is, alright, I hope you can guess it. If your answer is Conan Edogawa, you're right. And I still have the last one, and the cutest one among them. This is Pikachu. Pika Pika. Alright, what is the similarity among them? Yup, they are detective. Most of the time, detective is portrayed while he holds an instrument. And now we will learn about that instrument. Can you guess what is it? I'm sure you know what we are going to learn since you have read the title of this video as well. So we will learn about this optical instrument called magnifying glass. This is actually a simple instrument that's made of convex lens that put inside a frame, and there's a handle to hold it. But all of that has the same basic function, like this one. Guys, can you see what that is written on your screen right now? It's okay if you cannot see that. That's quite small. We can put a magnifying glass on it and we will be able to see this. So the function of magnifying glass is to make an image of an object, which says that image supposed to be bigger, upright, of course, because you are not expecting to get the letters are shown upside down. So we need the upright image. Then it's supposed to be virtual, since you are not going to show that through a screen. You just need to see through that lens. Back to the basic idea that magnifying glass is made of convex lens, the next question will be, when will it make bigger, upright, and virtual images? You must remember the idea about lens from previous lesson. The lens will produce bigger, upright, and virtual image if the object is put between focal point and lens or at its focal point. And in addition, because during the observation we will use our eyes, we must consider the accommodation power of our eyes. The important thing is the difference between seeing object with maximum accommodation and minimum accommodation. Our eyes will be at maximum accommodation when we see a closed object that is located at our near point or punctum proximum, like when you are reading, focus studying, watching a video on your cell phone, and so on. At this condition, rays will come to your eyes as shown on this animation. And our eyes will be at minimum accommodation when we are observing a distant object, like when you are daydreaming in the middle of a lesson. And at this time, rays will come to your eyes as a parallel one. This minimum and maximum accommodation during the observation will affect the magnification of the image that will be formed by magnifying glass. Before we learn about that, first we must understand that the closer the object to our eyes, the bigger the object will be seen by our eyes. And it's caused by the angular magnification. Because of this, we can observing a 500 Indonesia rupiah coin that will be bigger than a moon. Even though the actual size of the moon is much bigger than a 500 coin, but because the coin is closer than the moon, we can use a coin to cover a moon entirely. And it's because the angular magnification, as you see on the diagram, without any optical instrument, there will be a theta, angle subtended at the eye by the object when not viewed through the instrument. And on the next diagram, there is theta prime. angle subtended at the eye by the image formed by an optical instrument. The angular magnification actually is the ratio between theta prime and theta, whereas theta prime is angle subtended at the eye by the image formed by an optical instrument, and theta is an angle subtended at the eye by the object when not viewed through an instrument. We are going to generate the formula to calculate the magnification of magnifying glass. Actually, this formula generation will not be appear on your test at this level, but we will learn deeper so that you got more knowledge and understanding about it. First, we need some math theory. Here is the trigonometric theory. Let's say we have triangle with one of the angle is called as theta, so we can name sides on that triangle. A as adjacent side, B as opposite side, and C as hypotenuse. Tangent theta can be counted as the ratio between opposite side to adjacent side. And for small angle, tangent theta will be equivalent with theta itself. So that back to the equation of angular magnification that equal to theta prime over theta is actually equivalent with tangent theta prime over tangent theta. Now we learn about magnification in observation with close fiction or maximum accommodation. Without magnifying glass, observation with close vision require object to be put at our near point or punctum proximum, and we can call it as PP. And when we use magnifying glass, the object must be put at the distance between focal point and magnifying glass with the expected image that will be created at near point or PP. So the magnification will be equal to theta prime over theta. Since theta prime equivalent with tangent theta prime and theta equivalent with tangent theta, we can write m as equal to tangent theta prime over tangent theta. Tangent theta prime will be equal to h or the height of the object over do or distance of the object, and tangent theta will equal to h or the height of the object over pp or the punctum proximum. The problem here is we haven't known the distance of the object or do. So let's take a look at the ray diagram to simplify this equation. From the information on the ray diagram, we can use this famous thin lens equation. With do is distance of the object, di is distance of the image from the lens, here magnifying glass, and f is the focal length of the lens or magnifying glass. Since the image will be virtual, so the value of di will be negative. So the equation becomes 1 over do minus 1 over di will be equal to 1 over f. As we see on the diagram, the image will be formed at near point or punctum proximum. So it means di will be equal to punctum proximum or pp. So the equation becomes 1 over do minus 1 over pp equal to 1 over f. Let's make 1 over do as the subject, so that 1 over do will be equal to 1 over f plus 1 over pp. Then we are going to get do by first make all terms in right side to have the same denominator. So we have 1 over do equal pp over f times pp plus f over f times pp. Then we can write it as 1 over do will be equal to pp plus f over f times pp. And at the end, we have do will be equal to f times pp over pp plus f. This value will be put back on the magnification equation. Since m equal to ho over do divided by ho over pp, and do is equal to f times pp over pp plus f, then we can rewrite the equation become m equal to ho divided by f times pp over pp plus f over ho over pp. Then it can be written as m equal to ho divided by f times pp over pp plus f times pp over ho, and we can eliminate ho and get pp over f times pp over pp plus f, and it can be written as m equal to pp times pp plus f over f times pp. Then we can eliminate pp and get that m is actually pp plus f over f. Or it's same with m equal to pp over f plus f over f. Then at the end, voila, we will have m equal to pp over f plus 1. This is the famous equation of magnification of magnifying glass if observed with maximum accommodation. So in observation with close vision or maximum accommodation, you must put the object between f and lens, and the image will be formed at near point or punctum proximum. And the equation to get the magnification is m equal to pp over f plus 1, whereas m is actually the magnification, pp is the punctum proximum or near point. Usually for normal people, it's range from 25 to 30 centimeters. And f is the focal length of the convex lens on magnifying glass. Usually it will be measured in centimeter. The next one is magnification in observation with distant vision or minimum accommodation. At this condition, the object must be placed at focal point so that it will create an image at infinity, and it will allow parallel rays come to our eyes. The angular magnification will be m equal to theta prime over theta, or m equal to tangent theta prime over tangent theta. As you see on the ray diagram and use the equation before, tangent theta prime, or the angle subtended at the eye by image formed by an optical instrument, can be written as HO over DO, and tangent theta, or angle subtended at the eye by object when not viewed through the instrument, is equal to HO over PP. So the magnification can be written as m equal to HO over DO divided by HO over PP. And since TO here, or the distance of the object here, is actually the focal length, m also equal to HO over F divided by HO over PP. Or we can write it as m equal to HO over F times PP over HO. We can cross HO and get another famous equation in magnifying glass. That's m equal to pp over f. So in observation using magnifying glass with distant vision or minimum accommodation, the important thing is object must be placed at focal point or f, and the image will be formed at infinity. The magnification during this observation will be pp over f, whereas m is a magnification, pp is the punctum proximum or near point. As usual, it ranges from 25 to 30 centimeters for normal people. And f, the focal length of the convex lens, it usually measured in centimeter. Alright, if you feel bored about the explanation before, don't worry, because these are the main points on this lesson. Please don't skip this part. So magnifying glass is actually used to produce a magnified or enlarged object. So the aspecting properties of its image will be bigger, upright, and virtual. There are two types of observation. The first observation is by close vision, or we call it with maximum accommodation. At this observation, object must be put between magnifying glass and its focal point, and the image will be formed at near point or punctum proximum. And we can find the magnification by using the formula m equal to punctum proximum over the focal length plus 1. And the other observation is with distant vision, or we call it with minimum accommodation. At this observation, the object must be put at its focal point so that the image will be formed at infinity. And the magnification can be counted as m equal to pp over f, whereas pp is the punctum proximum. For the normal eyes, it ranges from 25 to 30 centimeters, and f is actually the focal length of the magnifying glass. The example problem about magnifying glass is like this. So the question is, an emmetropic person is observing an object using magnifying glass with plus 20 diopter of lens power. Calculate the object distance from the magnifying glass if it's observed with maximum accommodation, magnification of the image when it's observed with maximum accommodation, and then the object distance if it's observed with distant vision or minimum accommodation, magnification of the image when it's observed with distant vision or minimum accommodation. Alright, to solve this problem, the very important point you must understand when it say about imetropic one, so it's been talking about the normal eyes. So the punctum proximum or PP will be equal to 25 cm. And it said that plus 20 diopter of lens power. So it means the power of that lens is actually plus 20 diopter. So we can write it as P equal to plus 20D. So from that statement, we can get given information from this problem is PP equal to 25 centimeter and P equal to plus 20D. And the question is quite clear for A and B. It's asking about DO and M, the distance of the object at magnification, when it's observed in maximum accommodation. And question C and D is asking about DO, or the distance of the object, and also the magnification when it's observed in minimum accommodation. First, we must find the value of f, or the focal length. You must remember the equation about the power of lens, or here P equal to 100 over f, whereas P is the power of lens and then f is the focal length of the lens. On this question, P is supposed to be plus 20, so P is plus 20, and then f is the one that we need to find. We can change the subject of this equation, so you will have f equal to 100 over 20. So f is actually equal to 5 centimeter. So the focal length of the lens in this magnifying glass is 5 centimeter. It's positive or a convex lens. Okay, now we start answer the question. Start from A and B. It's about the observation with maximum accommodation. Since it's maximum accommodation observation, so DI or distance of the image will be formed at near point or PP. And its value is around 25. For the normal eyes, usually we can use 25 centimeters. And DO is supposed to be between lens and f, so its value must be less than the focal length. In order to find DO, we can just use the thin lens equation, whereas 1 over DO plus 1 over DI will be equal to 1 over f. Since the image will be virtual, so the value of DI will be negative, so we can write it as 1 over DO minus 1 over DI will be equal to 1 over f. And since the image will be formed at near point, so we can rewrite this equation as 1 over DO minus 1 over PP will be equal to 1 over f. And the value of a near point is 25, so we can write 1 over DO minus 1 over 25 will be equal to 1 over f, since the focal length is 5. So we must make 1 over DO as the subject of the equation, so you will have 1 over 5 plus 1 over 25. So 1 over DO will be equal to 5 over 25 plus 1 over 25, or 1 over DO will be equal to 6 over 25. So DO will be equal to 25 over 6, or 1 over 6, or it's equal to 4.17 centimeter. Then to get the magnification will be count as PP over f plus 1. So the punctum proximum or near point is 25, the focal length is 5, so we can get m is equal to 25 over 5 plus 1, or m equal to 5 plus 1, so the magnification is actually 6 times bigger than its object. Okay, now we will answer C and D. For C and D, the observation is with minimum accommodation. So the image will be formed at infinite, so DI will be infinite, and the object must be put at focal point, so DO will be equal to f. So to answer C is quite easy because the object must be put at its focal length. So DO will be equal to F. So DO equal to 5 centimeter. And to get the magnification will be count as PP over F for the minimum accommodation. So M equal to 25 over 5 or M equal to 5 times. So it means the image will be 5 times bigger if we observe it with minimum accommodation. Alright, at the end I have 2 questions for you and you can try to solve it. Alright, thank you for watching and let's hope the world will get better soon. And for you, please stay safe, stay healthy, and may God bless you. Thank you.